Okay, we are looking at 3-4, day 3, and this is going to be our last day of notes before review and quiz. So I first just want to do some examples where we're still reviewing that power rule. You really have to get good at this skill. So our power rule said if we had a function with x raised to some power, that the derivative is just that power times the coefficient out in front, so that would be n times a, and then x raised to the 1 less power. Alright, now I want to go over some special things today with negative exponents and radicals, all things you should remember from Algebra 1 and Advanced Algebra that sometimes gets forgotten because you haven't used it a whole lot. So just write in, we're finding derivatives. So if f of x equals 1 over x squared, as of right now, I don't think we had any of these, but what you need to do is use your negative exponents to rewrite this so that the x is up in the numerator. And remember, a negative exponent just means that the term isn't in its happy place in the fraction. So what I can do is bring this x squared up to the top, and then I've just made it unhappy up there, so this just becomes x to the negative 2 power. So bringing it up, if it's positive in the bottom, when you bring it up at the top it becomes negative. Now it's all set for me to do power rule. Notice how I didn't say I did derivative yet because I didn't. All I did was rewrite this equation with a negative exponent. Now I'm going to do the power rule, so now I'm doing the derivative, so I've got the right notation. So the negative 2 comes down as a multiplier, times x to the 1 less power, gives me negative 3, and that one's done. Next one, something like this, 5 minus 3 over 4x. Okay, now here, again, it's only the x that's the problem here. The 4 in the bottom is fine. So you want to rewrite this, not derivative yet, as 3/4 times 1 over x. And if you take a look, if I multiply the 3 and 1 together, 4 and x, I get that fraction back, so I just kind of broke this apart. Now I'm going to take this one and rewrite it with a negative exponent. So no derivative yet. Oops, that was a minus. 5 minus 3/4. Rewriting this is x to the first down here when I bring it up. It's unhappy. And now I'm ready for derivative. So y prime, derivative of a constant is 0. Here the negative 1 is going to get multiplied by the negative 3/4. 1 less power. Done. Let's go g of x equals 2x to the 4th plus x minus 14 all over x squared. Okay, again, we can't have this x down in the bottom here. And what we basically have are parentheses that are kind of hidden. We've got to be able to get rid of those parentheses, and we get rid of it by distributing this x squared into all of them. And I think the easiest way to do that is to rewrite this as a negative exponent to bring it up and then distribute it in. So the numerator stays 2x to the 4th plus x minus 14 in parentheses, and then I can bring up the x squared as x to the negative 2. And now I can just distribute that in, then I'll be ready for derivative after that. So distributing in, I'll get 2, and when you multiply you add exponents, so 4 plus a negative 2 is 2. This is x to the first, adding a negative 2, you get x to the negative 1, and then minus 14 x to the negative 2. Now I'm ready to do derivative. Now the notation comes in, g prime. Be careful with all of that, because if you put the prime in the wrong spot, I will mark it wrong. So here, multiplying 4x minus 1x to the negative 2. This will become a plus 28 x to the negative 3. Okay, some radicals. Y equals square root of x. Keep it simple. Remember, a radical is just a fractional exponent. So this can get rewritten. Remember, that's a square root. There's like a 2 here, but we don't write it because that's the most common one. That's x to the 1/2 power. Now it's ready for power rule. dy dx. Again, just changing it up. It's the same thing as y prime. Equals, bring down the 1/2 as a multiplier to the 1 in front. X, subtract 1, we get negative 1/2. Number 5, y equals square root of x over x. Again, good idea to simplify first because we can't actually do the derivative with the x down here in the bottom. So I'm going to rewrite both of them. Rewrite this one with a fractional exponent. Bring this one up with a negative exponent. Now that I'm multiplying like bases, I add exponents. So this is all still y. I have not done any derivative power rule yet. Adding exponents. I'm going to get negative 1/2. Now it's ready for derivative. Negative 1/2 x to the negative. If I subtract 1 there, that's subtracting 2 over 2. That'd be negative 3/2. Let's see, y equals, let's go, the cubed root of x squared. Okay, something like this we want to rewrite. Remember, that's a 1/3 power, and I've got an x squared. So I've got x squared to the 1/3 power. When I multiply here, remember, power to a power, you multiply. Back here, when we were multiplying, you add exponents. So when it's a power raised to a power, it's multiply. And if you put that over 1, you're going to see the numerators get multiplied, denominators. And this becomes x to the 2/3. Still have not done derivative yet. Don't think that's derivative. That's only simplifying this to get it into the form where we can do power rule on. Bring it down. 2/3. X, subtract 1. I'm going to get negative 1/3. Subtracting 3/3. And our last one of these, before we get to the story problems, I'm going to squeeze it in here. Let's go y equals the 5th root of x plus 4 times the cubed root of x. So rewriting first, so still y. This will become x to the 1/5. This will become 4 times x to the 1/3. And now derivative. 1/5 comes down as a multiplier. Subtract 5/5, I'm going to have negative 4/5. Multiplying down, I'll have 4/3. X to the, so negative 2/3. Okay, moving into some story problems from the book. The application of derivative and how you're going to have to be able to know in the story problem what tells you to do derivative. Here we've got, so we are on example 8. This is number 24 right out of your book. But we've got Chuck standing atop a cliff, throws his math book into the air with an initial upward velocity of 20 meters per second. As a result, its height above the water. So the height in meters above water after x seconds since he threw it, is given by this equation. Negative 5x squared plus 20x. And I do think it's a good idea to take a quick look at the graph. Where negative 5x squared plus 20x. Okay, this is the part where we want to see it, so I'm going to change the window a little bit. 0, probably 7. The y, 0, that went up a little higher. I'm going to go, how high can he throw his book up in the air? How mad is he? 25? Let's see. Oh, yeah. Okay, there goes his book. All right, questions. Write an equation for the velocity of the book. Remember, velocity is the rate of change of distance over time. Rate of change distance over time, divided by time. That tells us to do the derivative of the distance equation. So h prime is the velocity equation. How fast the book is moving at each time value. So if we do derivative, let's see, that'll be negative 10 x to the first, derivative here, plus 20. Okay, so we've got a velocity equation. How fast was the book going after 3 seconds? How fast at x equals 3 seconds. How fast is a velocity? We've got a velocity equation. All we've got to do is plug the 3 into the velocity equation. So negative 10 times 3 plus 20. So that's negative 30 plus 20 is a negative 10, and we do want units. And let's see, we were doing change in distance was meters per second. So negative 10 meters per second. Let's see, go back to this. I'm going to have to see down in the negatives here. Negative 20 will go to. So if I was to trace on this distance graph, it's going to tell me the distance that it's at from me. So trace to 3. There's the distance. It's 15 feet above where I'm standing, but it's moving at negative 10 meters per second. And what does this negative tell me about the book? That the distance from the ground is decreasing, so the book is coming back down. So the negative is an indicator that the book is coming down. Dropping. How's that? Okay. Then it says, at what time is the book at its highest point? What time is the book